If you want AI systems to cite your content, you first need to understand how they actually find information. Large language models have access to knowledge through two fundamentally different mechanisms. The first is parametric knowledge. This is what the model knows from training, information encoded directly into its neural network weights. It handles general knowledge, patterns, and concepts, like knowing the capital of France is Paris. The catch is that it is frozen at the training cutoff date and can be imprecise. The second is non-parametric knowledge, which is retrieval. This is external data the model fetches in real time while generating a response. It is used for current information, specific facts or documents you upload, like citing today's news from Reuters. Its limitation is that it depends on search quality and source availability. Let's look at how training works. In simplified form, models are trained on massive datasets in 4 steps. First, data collection gathers billions of pages from the web, books, and other sources. Second, that text is processed. It gets tokenized and patterns are learned. Third, the model adjusts its weights as it learns to predict likely next words. And fourth, facts and patterns become embedded in those weights. Now, not everything encodes equally well. Common knowledge, language patterns, reasoning patterns, and frequently referenced sources stick. What doesn't get encoded well is just as important for you. Rarely mentioned facts, anything published after the training cutoff, highly specific details, and information from low-quality sources tend to get lost. That last list should shape how you think about getting your content into a model's memory. Not all web content makes it into training data. There is a selection process. Content that is likely included looks like this: Wikipedia and encyclopedic content, major news outlets, academic papers, popular high-quality blogs, government and institutional sites, and well-established company documentation. Content that is likely excluded includes paywalled content, in most cases low-quality or thin pages, spam and SEO manipulation attempts, very recent content, and private or restricted sites. So what does this mean for generative engine optimization? 4 things. Publish authoritative content that other people reference frequently. Build a reputation that leads to citations elsewhere on the web. Make your content publicly accessible, not locked away. And focus on quality over quantity, because thin content simply does not make the cut. Now for the second mechanism, real-time retrieval, like ChatGPT with web browsing or Perplexity. The process has 6 steps. First, query formulation, where the model converts the user's question into search queries. Second, those queries are sent to search engines or databases. Third, the returned results are ranked and evaluated for relevance. Fourth, relevant portions are extracted from the pages. Fifth, the model synthesizes that information into an answer. And sixth, sources get cited in the response. So what determines whether your content gets retrieved? 4 factors: search ranking, because higher ranked pages are more likely to be included; content relevance, meaning your content must match the query intent; freshness, since recent content may be prioritized for current topics; and accessibility, because your content has to be crawlable and parsable in the first place. Here is something many people miss. Even when your content is retrieved, the model still makes a decision about whether to actually cite it. Content is more likely to be cited when it contains specific, factual claims, when the source appears authoritative, when the information is verifiable, when it directly answers the question, and when multiple sources corroborate the same information. On the flip side, content is less likely to be cited when it is vague or opinion-based, when the source lacks credibility signals, when the information cannot be verified, when it is only tangentially related to the question, or when it contradicts trusted sources. Notice the pattern here. Specificity, authority, and verifiability keep coming up. If your page makes concrete claims that other trustworthy sources back up, you win the citation decision. There is one more technical constraint you need to know about: the context window. This is the amount of text a model can consider at once, and it is limited. GPT-4 handles up to 128,000 tokens, Claude up to 200,000, and smaller models often just 4 to 32,000. Why does this matter for GEO? When models retrieve content, they can only use the portions that fit in the context window. So your content needs to do three things: get to the point quickly, with key information near the top of the page; be self-contained, so important facts do not require reading other pages to make sense; and be concise, because longer is not better if your key points are buried deep in the text. Finally, when generating responses, models prioritize information in a clear order. Direct instructions from the user come first, then retrieved real-time content for current or specific queries, then high-confidence parametric knowledge, the well-established facts, and last, lower-confidence knowledge, which may be hedged or qualified. For GEO, this means being in real-time retrieval results gives you priority over training data alone, while training data inclusion provides a baseline presence. Ideally, you want both. That is the full picture: two knowledge types, how training selects sources, how retrieval works, what wins the citation decision, and why concise content matters. You can test this yourself right now. Open this lesson at freeacademy.ai and use the interactive prompt playground, or paste a question into ChatGPT or Claude, and watch which sources it retrieves and cites. In the next lesson, we cover RAG systems and how AI-powered search differs from traditional search.